This lesson will not only go over what the exponent rules are, but I'm going to demonstrate where they come from, and so that you can better understand them. Remember what exponents or powers mean. Repeated multiplication, and an example would be 2 to the 5th means 2 times 2 times 2 times 2 times 2. All the rules come from shortcuts from using the basic power principle. So let's take the first one. Let's take a squared times a to the 5th. What that means using the power principle is a times a times a times a times a times a. So there's 2 red a's and 5 purple a's. And when you multiply all of them together, you realize you're multiplying 7 a's together. So you get a to the 7th. So that's how we came up with the multiplication rule. You're going to add the exponents. So a squared times a to the 5th equals a to the 2 plus 5, which of course equals a to the 7th. Our next set of exponent rules, we're going to take a squared and we're going to raise it to the 4th power. What this means, again using our properties of powers, this means a squared times a squared times a squared times a squared. So a squared multiplied 4 times. Or if you wanted to break it down completely, a squared, so there's 2 red a's for a squared, another 2 for the second a squared, another 2 for the next a squared, and the last 2 for the last a squared. Either way, even if we used our basic principle, 2 plus 2 plus 2 plus 2, we're going to get a to the 8th. So our power rule, the shortcut, is simply that we multiply the exponents. So a squared to the 4th power means I'm going to have a to the 2 times 4, and that equals a to the 8th. Now let's do the next one. A to the 5th divided by a cubed means a times a times a times a over a times a times a. So using rules of fractions that any number divided by itself equals 1, we can get the following, and you'll notice here that I've canceled out an a on the top and bottom, and there's a total of 3 that match up. So all of those reduce to 1. And I'm left simply with a times a on the top, so my answer is a squared. And there's our division shortcut. The division rule says to subtract the exponents. So a to the 5th divided by a cubed equals a to the 5 minus 3, or a squared. Let's continue with the exponent rules. Now we're going to get to one that's a little bit more complicated for some students to comprehend, and that is a to the 0, so anything to the 0 power. So first, let's see how you could get a 0 exponent. So I took a squared divided by a squared, and if I use the subtraction rule, 2 minus 2 gives me 0, so I end up with a to the 0. So now let's think about this. We know that any number divided by itself is 1. So a squared divided by a squared, as I showed earlier, must equal 1. So that gives us the following rule. The 0 power rule. Any number raised to a 0 exponent is the whole number 1. So in our case, if I took a squared and raised it to the 0 power, I would literally get the whole number 1. The a would be gone. It would just be the whole number 1. So this page sort of proves why a to the 0 comes out to be the whole number 1. Let's continue with the exponent rules. Now we're going to talk about negative exponents. So let's example a to the negative 1. Here is an example of how we could get a negative 1 exponent. A squared divided by a cubed. When we use the division rule and subtract the exponents, we get a to the 2 minus 3, and so we get a to the negative 1. Now let's continue to look at that. from the basic principles of powers and fractions, and we're going to prove this. So again, you'll notice I wrote a times a on the top of my fraction, and a times a times a on the bottom to represent a squared over a cubed. Now again, you'll notice as we reduce, a divided by a is 1, a divided by a is 1, and so basically I'm getting a 1 on the top of the numerator and a on the bottom. We get 1 over a, which leads to the following rule. The negative exponent rule. Any number raised to a negative exponent is equivalent to the fraction 1 over the number to the positive exponent. So a to the negative 1 is equal to 1 over a. So here's a couple examples. Here's a to the negative 3. Well, that is going to convert to 1 over a to the positive 3 power. Or let's take it with numbers. 2 to the negative 3 power would equal to 1 over 2 to the positive 3 power. Now it is a number, so we can actually evaluate 2 cubed. So in the end, my answer is going to be 1 over 8.